As an alternative to SPSS, you could use R to do the meta-analysis. The disadvantage of R is, or also its advantage, is it's not menu driven. It's a scripting language. This means that learning how to use it has quite a steep learning curve. But once you get used to using it, it's not actually that difficult to use, because a lot of the functions and things you want to do have been built in by other people and operate automatically. This is particularly true for doing the meta-analysis. So the first thing you need to do is install the special tools that you're going to need to do the meta-analysis. I've installed here a couple of sets of libraries that include special colours for colour blindness, and I've included the package, the library called Meta, which does the meta-analysis. So the way that R works is you type the commands that you want it to do, and it does that operation, and then it will generate your images. So this is all within RStudio. You could run it on its own if you want to. It's much easier to do within RStudio. The way I prepared this was I have a template file which looks like this, and you just customize it to change the parts that are specific for your project. So in this case, the things that are specific for the project is the name of the data file that contains the data, the separations and the headers. So some information about that data file. In general, the columns in all of the different data files will be the same. That's why I said to use the column names NE, ME, SE, NC, MC and SC, and authors and year. So this line here is the thing that carries out all the meta-analysis. Once that analysis has been performed, it creates something called Model 1. And inside Model 1 is all the data that you need to do all of the other plots. So to do the forest plots, you do forest of Model 1, and then this specifies some conditions to say how you want it to look. And then when you want to do the funnel plot, you do funnel Model 1. And again, these are some extra details that I've put in to make it look slightly better than just the default. Once you've got a script like this, to run it, you just put the cursor at the start of the line and you press the run button in RStudio and it runs through each one. Now, as I'm running through the commands, it's telling me what's happening down here in the console. So it's telling me whether the program's run successfully or if there's a problem. This first line says data, read the CSV file, which is called this CSV file. The top line is going to be a header, and the separator is a semicolon, not a comma in this particular thing. We saw that in one of the earlier videos. So you might have noticed that then this thing popped up over here, an object, a thing inside R called data. If I click on data, this is what's stored inside data. So it's just like the spreadsheet. It looks exactly like an Excel sheet. It's rows and columns of data. So if I go back to my meta-analysis thing, I can then run the next thing, and this creates something called Model 1. If I try clicking on Model 1 like I did on data, I can't actually see the things, because Model 1 is actually a holder for many different tables. So instead of it being like a single sheet from an Excel spreadsheet, it's more like an Excel file, which can have multiple sheets. So each of these things contains different sets of data associated with that model. So these are the different things that are going to be used to plot the forest plot and the funnel plot. To create the forest plot, I run the forest command, and the forest plot appears here in the image window. This one is in the format for the Journal of the American Medical Association, and I've included a predictive line here. you can see that there's two diamonds. One is for the random effects model, one is for the common effects models. And you've got two dashed lines corresponding to the mean values of these two models. It's interesting to note that if you had a fixed effect or a common effect model, it is actually significant because the diamond does not contain the zero effect model. The prediction interval is over a much wider scale, so these are the reliable regions for the predictions. So that's where you know, well, you suspect the predictions are going to lie within that region. If I go to zoom, if I zoom this thing, it's probably appeared in a, it hasn't appeared in one behind. Yes, plot zoom. So I can have a separate window which allows me to see it at a much larger scale. Within R, I can export that. So from within the zoom window, I can say save image as, and I can save it as different types of files. So this one is a PNG file. There are other ways of exporting it if you use the export button here. So save as image, I can do as PNG, TIFF, SVG, EPS, depending on what I want to use it for. The other plot is the funnel plot. So if I run the funnel plot, I get this funnel plot, which is a more sophisticated version of the funnel plot. And let's plot the legend as well. Where's the legend? Not there. That's better. So I've got the legend on my funnel plot. If I zoom it. So what does this funnel plot show? So here is the meta-analysis. Here is the mean effect. And here is the zero effect. So this is if there's no difference between the treatment and the placebo. So this white triangle represents all the studies that you wouldn't find any effect. When you get to these light blue studies, these are studies where you're seeing a p-value for the effect between 0.1 and 0.05. And in this case, there's one study. Then, as they get more convincing, they have stronger effects and bigger effect sizes. So the p-values become smaller and smaller. You get into this second light blue zone and then into the darker blue zone. So this negative, no effect one, which is Sahin, is a very small p-value, negative effect. And this is Vas and Cerezo-Teles, which are very small p-value, positive effects. So very large effect size, negative and positive. And here's your regular funnel plot, the one that matters. So if you look at this, this means that almost all of the studies that we've included in this meta-analysis didn't show any effect size. But you had 3 studies that did show some effect, 2 of them a large effect, 1 of them a smallish effect, and 1 very large negative effect.